Okay, so hello from Fab Lab. I'm Chris, and today I'm going to do a follow-up video about how to use KiCAD and mods and SRM-20 in order to mill and solder your double-sided board. So there are some things that I didn't mention in the previous video that I was struggling with. So in KiCAD, it can be tricky to actually prepare the design so that it's symmetric and that your the front traces and the back traces of your board match up. So in this video, I'm going to cover how to get that sorted out so you can mill your boards properly and you can get your boards to a state that they actually work like this one. Okay, so let's get started. So here, this is KiCAD. So this is where we left off last time. So I could also make it full screen like this. So as you see, we are using here an ATtiny 412 chip. So there's a bypass capacitor here. Then there's an LED connected. So that's, and then other things that are connected to the FTDI chip. So there are basically two connections here. So one is the UPDI chip, which you use, UPDI connection, which you use for programming the board, and then the FTDI chip, which you would connection that you would use for communicating with a computer. And there's a power LED that basically should turn on whenever your board is connected to the FTDI connection. So it will just be the first indication that your board works, that electricity is provided, and then the programmable LED, which you could then later program, so which you should do this week as well, and a button, so you can choose whether you want to add that to your program as well. But yeah, it's better sooner than later. But yeah, the schematics is one thing, but what we are actually interested in is the PCB view. So this one here, when we were finishing the video last time, it was that we had like these sort of things all over the place somewhere, laid out randomly like this. There were also some things like these footprints that were reaching over the edge cut layer and also the margin layer. And what I did, I had to do two things in order to fix it. I had to edit the footprints, and I also had to move everything that is outside the board, outside the margin area, inside. And for one reason, to make it symmetric. So the margin, so the space between margin and edge cuts, they should be the same. And I can show you how I did it. So let's assume that, so these lines are rather somewhere here, or the margin layer itself, it's non-existent. So I'm going to delete those. So the first thing I would do is I would select the margin layer as the active layer, and then I would go to the graphic lines tool, and I would draw a line that perfectly matches the edge cuts layer. That can be considered as a bounding box of the edge cuts layer. Like so. And how do we offset it? So there's no easy to use offset feature as it is in Illustrator or Inkscape, for example, or like any other software. So you have to select the line, hit E to open the preferences. And here you can see these four fields. So start point, it's not indicated that it's X and Y, but it's the top field is X, the bottom field is Y, and for the end point, the same. And we want to offset along the x-axis, and I had it offset by 3 millimeters, but 2 millimeters is fine. So I'll add 2 millimeters on top of this value. So 163 is going to become 165. And the same goes for the x value of the endpoint, like so. And we want to add the same offset for the left margin line. And here, instead of adding up 2, I will subtract, and 133 is going to become 131. Like so. And what you do with the top and bottom lines doesn't really matter, so you can just I mean, how much they should be offset, but they shouldn't be offset by the same value. So I'm just gonna able position them like so. And yeah, I think they don't have to be even connected, so because they are more or less defining the bounding box anyways, so KiCAD is going to treat them as such. But if you want to be, if you want your design to be perfect, of course, then you can connect. Now I'm pressing and holding down Command key in order to keep these straight angles whenever I am dragging the endpoints. So that's done. And then the other important thing is to move these all these things that are on the front fabrication layer to be inside that area. So because what we are going to mill the front side, and we are going to cut the board out by using the edge cuts layer. So we want the bounding box of all the elements to be such so that the center line is always matching the center of the board. So otherwise, if we are going to flip it, the back traces are going to end up on the wrong place. So let's make sure that these are inside. Another thing is that in the design that we designed in the previous video, so these footprints were a bit different, so they had extra drawings, and you should edit them. And how you do this is you go to footprint editor, and you look up the library that we had. So we made a local library, which was this one, and yeah, let's open the FTDI header. And what we had previously was these lines here. And what we have to do is just to simply remove them. So we click on them and delete. Or first I will show how it would look on the board. So I'm gonna save this, close it, and then here I'm gonna hit update footprint. And this is how we had them previously. So let's assume that this was the previous view. And we go to footprint editor again. And then we go find our footprint, this one. And we have to remove this. like so, and then we save it. And we do the same also for this one, so the UPDI header, and if necessary also for the button. I think another way could be that you just can move it around separately. No, you cannot. Sorry. So, but now when the footprints are edited, it's not automatically being updated in the PCB editor. So you have to select the component and right-click and click Update Footprint in order to pull in the latest changes, like so. And now with these things done, we can move on to the next step, which is exporting. So we go to File, Export, SVG. And it's a step with several, it's a process of several steps. Just a sec. I'll need to delete the old files first. All right, so yeah, now I'm back. So let's start with the front layer. So what we want is the front copper layer and the drawings user. Also, yeah, whenever you change the edge cuts, so make sure that the drawings user layer fits the edge cuts, and you should edit it in a way so that the outline is 0 millimeters thick, so that you get the exact size of the board that you want to get at the end. Yeah, so when we edit the board, then we can hide it. Then when exporting, so instead of the edge cuts, we are going to export the drawings user layer. And make sure that it's black and white, that it's board area only. So this is where the margin gets important, because KiCAD is going to try to draw a bounding box around all the visible elements. Not just only the visible, but only all the layers that are there. So, and then define the board area depending on that. We don't want it mirrored. That's going to be for the backside. And one file per layer. Yeah, that's what we want. Unfortunately, I haven't found yet a way how I can export drills separately, so this is why we are going to use Inkscape. And then, so you uncheck the front copper and drawings user and select the back copper layer. And for this, we'll leave the same settings in terms of black and white board area, but we want this to be mirrored. And this is another reason why we need this to be symmetric. So why we need the board to be symmetric to the left and right from the edge cuts, because KiCAD is going to mirror it around y-axis, and this is why the symmetry is important here. Export, close. So now I'll go to the folder. Oh, wait a minute. Where it saved it. Wait. How can I exit this view? Yeah, so like this. So I'm gonna not this one, but this here. So I'm going to go to the solder folder where the SVGs are. So as you see, here's the front copper. There's the interior, and this is the back copper mirrored. So you can make sure that it's mirrored. You know, so when you go back here, and then you select the back copper in order to make it visible. And oh no, not this file here. It's the back copper. You see it's mirrored around the y-axis. So still the top side is where it should be, but yeah, but the left and right they're flipped around. And this is how you will need also to flip the board when you cut it out first. So and now what do we want to do? So this is what we want to extract these little dots from the front copper layer into a separate file, so we could actually use them as drill points. In order to do that, I will need to use Inkscape. I wish that there would be a way how not to use that. Maybe there's a plugin or something for KiCAD, but I'll find out later. So here we are in Inkscape, and all we have to do, just have to select the black traces because they are separate on a separate layer. The black traces, and just hit delete. And then we need to select all the points that are here and make them different from the background. And in order to do that, we can just click on one of the presets over here and make them black. And if you haven't done that already, you should use the save as, not save command, because it's going to overwrite the front copper file, which we don't want to do. And so we save it as drills. Just add drills to the existing file name here, and save, and close Inkscape. Next is to create toolpaths. And we can do that in mods. Yeah, I will try to make a video where you can use other software than mods. So we have also Copper PCB, which uses Gerber files in order to produce toolpaths. Yeah, but later. So now we use mods. So we we right click, go to programs, open server program. Then we choose PCB SVG, select the SVG file. Let's start with the front copper. Is it the, no, that's the other. So this is the file, this is the project that we want to target. So front copper layer, open. And yeah, remember to invert it because we want to mill around the white areas. Then let's select the mill traces preset, and let's enter exact values that we are going to use. 0.4 milling bit. We're gonna go 0.1 millimeter deep. We're gonna go 4 times around the traces. And what we need to do also is to replace the WebSocket device with a file, save file output. So modules, open server module, file save. Connect those. For the speed, it's very important to enter the right value for our bits. They're not so strong, so we need to go slower. 1.5 millimeters per second is fine. Then for the origin, center, so these should be all 0. This is fine. This 0, and Helm Z is going to be 5. And then we can hit calculate over here. So mill raster 2D, calculate. Here we go. Make sure that you save the file in a place where you can find it. And I would recommend you to. Can you let him in? I can give you the card. To open the door between there. So yeah, and let's make sure that we put it in the correct place. So Chris, KiCAD, design demo, so RMLs. So I made a new folder, RMLs. I had it previously, you might not have it, but yeah, so I'm gonna drag it there, and I'm gonna give it a name, front traces.rml, like so. I'm gonna close this one and select another file. I'm gonna select the drills file here now, hit open. And in this case, we do not need to invert because we want to mill from inside of these black ones. So remember that the white area is what is going to be left. So that's the copper that is gonna be left. And the black ones are to be removed. And in this case, we don't need to mill the traces. We need to choose the outline settings because we're gonna use the 0.8 millimeter bit. So let's enter exact values. And then for the cut depth, hello, I'm recording a video about how to make the board. So there's a few tricks that you should keep in mind. So in order to produce this double-sided, so there's symmetry. So you have to take care of symmetry. So this is a working board that I made yesterday. Yeah, so for the cut depth, you choose 0.6. The total depth of cut is gonna be 1.7. So it's, yeah, as if drilling a little bit over the edge of the board, over the edge of the, over the other side of the board into the support material. And then, so yeah, now we are going, we need to change the speed. So for the larger bit, we can choose 2 millimeters per second. We can leave the rest of it the same. And now we can hit calculate. And you see nothing happens because the holes are exactly 0.8 millimeters. And then when pixelated, they're even smaller. So that the calculation happens somehow. It doesn't. So the algorithm doesn't see the holes as being fit for drilling. So we need to. You need to tweak this value in order to make mods to understand that we want to cut from inside, so that these holes are actually fitting. Fitting the holes. So like this. In my case, usually 77 worked. And in this case, yeah, there's only one hole that is missing. It's over there. So another trick that worked was that I increased the DPI. Let's go here. Now there's another hole that is not matching. So I will set this to 1000. Hit calculate. Yeah, now all of them are there. So you can now take the latest file. Let's delete the rest so that we don't have extra confusion there. So let's move it here. And I'm going to name this as front drills. Now it's going to be easier from now on. So we select the next file, which is going to be the drawings user. So that's going to be the edge cuts layer for us. So we open it up, and what do we want to do? We want to invert it because we want to mill around this white area. This is where the hypothetical copper layer is going to be. We want to leave there, and we can leave the same settings. Just let's change the tool diameter to the one that we are actually using, 0.8. Everything else is pretty much the same. So speed 2 millimeters per second. So we hit calculate, and here we go. And we can show this in Finder, move it to our RML file directory, and indicate that we are cutting from the front side, and front outline RML. And lastly, let's select the back copper layer. And here we need to invert it as well. Hit mill traces, use mill traces presets, change it to precise values that we are going to use, 0.1 millimeter, 4 times around the trace. We need to set the speed back to 1.5 and hit calculate. Like so. And let's move it also to the RML folder that we have here. Let's call it back traces. So that's that. I'm going to use a flash drive to transport these to the other computer, which we are going to use for milling. And now I'm going to make a 5 minutes break and continue with the milling process. One problem is that there are not too many USB ports over here, but okay, I found one. I'm gonna use trackpad instead of mouse. Yes. So, so we continue with milling the board with SRM-20. Oh, that's a nice effect over here. Very good. So the first thing is to actually turn on the if I move the camera, we can see this one over here. Yeah. So first thing is to turn the machine on, so which you can do here on top of it. So like so. So it should go green. So this button over here, this one. So that's turning it on, and then so once the machine is on, we can open the vPanel software in order to control the machine. Like so. Just want to see, do we have it? Need a combined view. So yes. Yeah, so we open this up, and now we can set it to continuous movement in order to move the head around like so. And we want to start with milling the front traces. So this is why we are going to select a tool that is 0.4 millimeters, this one, and install it into the machine. So in order to do that, I'm going to flip this open. Just to make sure that it's clearly visible. Like so. As I said, remember to first insert the tool a bit more inside. So that we can set the coordinates, so the set origin easier. So now at this point I'm going to activate the 1 millimeter step or 100 step mode. So 100 steps translate to 1 millimeter on these machines, and I'm going to go as low as possible, but yeah, also taking into account that this gap here should be like in the range from like at least around 1 centimeter is fine. So something in this case it's around 7 millimeters or so. And then when it's like that, then we can release the screw, adjustment screw, and let the tool drop down until the level of the copper. And this is where we are going to set the Z. So click this button in order to set the Z origin. And you see that the Z here becomes 0. And now let's lift it a few millimeters and enable the continuous mode to move it where we want to have our XY origin. Now I'm going to switch over to 1 millimeter mode again to be a bit more precise. I'm going to set the X origin on the left edge, and then the Y origin wherever this previous cut ends, and hit XY origin. Yes, I want to set it there. Now I'm ready to close down the chamber like so, and actually start milling. Let's see, I just want to make sure then. This here doesn't have too many reflections. Okay, here we go. And yeah, and then in V panel we can go to cut, delete all, add, go to the flash drive of ours, here RMLs. Here I added numbers to the traces, so which so to kind of know which goes first, and also the tools that should be used with those RML files. You can do that as well. So as you see, for the front traces, the file size is the biggest as it contains the most instructions. You can even maybe try to calculate the time, the milling time, by using those. So yeah, let's hit open and output. Yeah, it started going fine, so let's just switch over to this view and wait till it finishes. Okay, so now, so the front side copper, so the front traces are done. So we can open this up. Before we do that, it's a good idea to transition here. Let's go to the control panel. You can hit view. Yeah, like so. And then I can open this up, and the view is going to work only if the lid is closed. Let's take a closer look at the traces. Oh, look good. Yeah, very nice. Now let's change the tool. So, because the next operation is going to be drills. So I'm going to take a 0.8 millimeter tool. And again, insert it a bit deeper into the collet. And set the Z axis. I'm not going to touch the XY, but the Z axis is important. So this is about okay. Let's release this so it hits the surface, and let's hit Z here. Okay, now we can lift it a few millimeters. We don't need to do anything with XY because it's already preset. So let's close it down, and I'm just gonna check. Could be a bit better. Like so. And let's load the G-code. I'm going to add the front drills and the outline. You can add 2 jobs also that are going to be run after each other. So, and if you click this, then it's gonna stop after each of the files, but we actually want to keep it going because both of these are using the same tool. And yeah. Now doing the drills. And the good thing is that we don't have to repeat this on the other side of the board. Alright, this is done. Now again, let's use the view button over here. And open this up. Nice. So now let's take a closer look. Yeah, the drills are there and they match the pads exactly as we expected. Well done. Now the next part is to actually remove the board. I'm gonna use a knife for the purpose and flip it over to the other side. So in order that to happen, we'll need to remove the tape from the back side of it. So from here. So yeah, you see the holes are also on the other side, and now we just need to mill the traces on the other side. So I'm not sure whether I want to use the same tape. Actually, the same piece of tape is good enough, so I can just put it on the front side over here, like so. And now I need to guess which was the side, how I need to flip it. So you should flip it not like that, but like this. So, and let's transition to this first. So let's put it in here, like so. So you should really decide for yourself whether you feel that the tape is strong enough or not. Then, so you should position in a way that it fits the pocket as precise as possible. So, and you can use something soft like this, for example, in order to press it a bit stronger, so it sticks better to the board, or sacrificial layer. Now, so we can install a new tool, so which is going to be again the 0.4 millimeter milling tool for the traces. So 0.4. Again, I'm inserting it a bit more up in there. Now I'm going to switch to continuous mode to position it above a place where I can calibrate nicely. Maybe the middle of the board, somewhere here. Actually, somewhere here is better. Sorry, machine. Now, down. Yeah, this is just enough. And release the tool so it drops. Nice. Now I can set the Z. Am I in the right view? Yeah, now I can set the Z. Yes, and lift it a few centimeters up. And now I can close the lid again. Go to cut, delete previous jobs, add, and the back traces. Open. Now put. Remember that they are already mirrored to match the flipped state of the board that we have now. Oh, it started to move. So this is where we have to stop. So this is why it makes sense to add fresh tape on the other side. And start milling from scratch. Okay, here we go. It's ready. Let's take a look. Let's take it out. Let's remove the tape. And that's the other side. So as you see, there's a small error on the top side which could be easily fixed, but otherwise the other traces, so the bottom trace, which is for the TX signal or RX signal, I don't remember exactly, that looks quite nice. And the next thing that I want to do, I would like to insert the vias, and first I'm going to do that. And then I'm going to add a little solder jumper. So I'm going to solder the components and also add a little solder jumper here to fix this top trace over there. First I'm going to remove the tool, so remember to do that always. So that if somebody else wants to mill right away after you, like unless the same tool has to be used, someone can use the milling machine right away. And also put the tool where it belongs. So on the side of the machine there's this one, so insert the tool here. So there are the 3 milling tools and the key, this board over here. So I brought it here in order to show you the via inserting process. I'm just going to clean up a little bit here. So the vias that we need, or the rivets, can be found in this box in the electronics tower. So two-sided PCB rivets, 0.608 millimeters. So 0.6 is the inner diameter, and 0.8 is the outer diameter. So this is why we made the holes 0.8 millimeters. So if you remember setting the net class for for the traces in KiCAD, then we set the drill diameter to 0.8 millimeters and the via size themselves to 1.6. So if you will measure carefully, then around the vias there, focus here, or on the board, better on the board. Come on, do it. Yeah. So if you take a closer look and you take a caliper, then you will notice that it's 1.6 millimeters around them. Let's see, so how precise are these? Do you see any offset over here? We actually managed to position the board quite nicely, and there's not much of an offset on the other side. So, okay. So yeah, the vias, these ones, rivets. So these are in the boxes. There are 1,000 pieces in the box. So you see, you have to be very careful not to drop them out, because you're not going to be probably very happy to collect them all around the space, and then a fraction of those is going to get lost. So always when you open it, then make sure that you close it as well. And I'm going to take tweezers, relatively sharp tweezers. Yeah, something like this. And I'm going to take a few vias out, so 2 as a starting point. And what I'm also going to do, I'm going to put them in a place where they do not necessarily move around, because I'm going to use but the trick is, yeah, this is the via. The trick is that you have to insert it in one of these holes. Alright, so this is what we are going to do. So I'm going to place the via, the other one somewhere where I can access it, where it doesn't vibrate so much. The other thing that we will need is the double-sided PCB rivet punch tools found in this box. And there's a sharper tool that looks like this, with a Sharpie on the one end, and then like a flat tool, which is a bit wider on the top and narrower on the bottom. It's kind of to concentrate the force that we are going to apply with a hammer to a certain area. Okay, so let's arrange this so that it doesn't fall over too much. Okay, so you need these 2 tools, and then this thing is the via. So for a reason, it's 0.8 millimeters in the outer diameter and 0.6 in the inner diameter. What do you have to do? You have to insert it in one of these holes. Oh. It's easier to do under a microscope and with more light. So you insert it in, so it kind of snaps a little bit. It's better to have the hole a tiny bit smaller than bigger, and then you flip it around carefully so that it comes out on this end a little bit. Actually, it would make sense to clean the board before you do this a little bit. Pack pads and a little bit of medical grade isopropanol, so which can be found in this box over here for cleaning optics only, but I'm gonna use it for cleaning PCBs. And just to remove the fatty layer. And then what do? You insert this, the sharp part of this tool in the middle of the via. So you'll be able to feel it, that it fits. And then you use the hammer, like a few times, like 1 time, just to fold it over. So if you zoom in, I think here, maybe you can see now. On focus, it's so the edge is gonna fold it over. Can you see? Like it's gonna folding over, and then in order to make it complete, you use the flat tool. So you put it over, and then I usually just hit 3 times on one side, and then maybe one side on the other, one time on the other side as well. And then it kind of melts together with the board. Yeah, as I'm gonna do the soldering part under the microscope, and then it's gonna be better visible. Okay, let's do it one more time. Yeah, now we got it. And as you see, it's a little bit above the surface. And now we can use one of the tools here, the Sharpie tool, and insert it in the middle of it. Fold it over a little bit. See at an angle, it has now a slight V shape over here. And then you can use this flat end in order to put it on top of this. And then you can use a hammer. Now let's take a closer look. Okay, it's perfect. Let's source the components. These pads. Over here. First we are going to deal with a chip. So we identify where the first pin is, and that's usually, you can see that by finding this white circle on one of the corners of the chip. That's first I apply a tiny bit of solder on the edge, the corner pins.
It's 3 o'clock.
Bypass capacitor. Okay. So a little bit more so. sit down and put going. Yes. Just using my solder. That's pretty much it. So what happens here on the front side? There's this thing coming up from one of the vias. Not enough. Why does this heat up so much? Didn't melt for some reason. For some mysterious reason. Okay, let's try to program it. It's double-sided, fixed, debugged, not really debugged, but I'm gonna go and try to program it next.